Hello friends, this is a basic lecture of group theory in which we are going to cover some basic terms like what is group, order of the group, abelian group, generating set, etc. So let's start. What is group? Group is a algebraic structure like which is satisfying all these three properties. Let G under star, star is a binary operation. What is algebraic structure? A set equipped with one binary operation on it is called an algebraic structure. So, what is binary operation? Binary operation is basically a function from, if we are talking about if binary operation on G, so star, or we can say F or star, anything, star from G cross G to G. So this is a binary operation. That is, if you take any two element a comma b from this set G, so and you operate them with this operation a star b, this will also be the element of the G. It can also be said that it is a closure property. So algebraic structure, if you are saying that G star is an algebraic structure, this is equivalent to the closure property. So this means closure property of the set. Now, G is said to be a group if these three properties are satisfying. First is associativity. That is, if you take any three element of the group G, sorry, not G, this is now set. So if you take any three element of the set G and you operate them like this, and if they are equal, so this is the associativity. If second property is existence of identity. If there exists an element E belong to G such that A star E equal to E star A equal to A for all A belong to G, this implies that existence of identity. Now third property is existence of inverse. If for each A belong to G there exists B belong to G such that A star B equal to B star A equal to E, then we say uh, inverse of each element of G exists in G. So if these properties are satisfying for an algebraic structure G under star, then we say that G is a group. Now what is abelian group? Abelian group is the group basically. If we have a group which is satisfying this property that A star B equal to B star A for all A belongs to G, then we say that this is an abelian group. This is nothing but the commutativity property of the elements of G. So this is the abelian group. Now next term is order of the group. If you have a finite set G, if we are talking about a group, this is also a set. So yes, in set we have elements. If this is a finite set, then cardinality of G. What is cardinality of G? Cardinality is basically the number of element in a set is called the cardinality of the set. So cardinality of G is the order of G if G is a finite set and denoted by O of G. We say this order of G. And if G is an infinite set, then we say G is an infinite group. So then we don't have any finite number which is the order of G for an infinite set. Now next term is cyclic groups. What are cyclic groups? Uh, before no. So what is cyclic group? A group G is said to be cyclic if there exists A belong to G such that set generated by A equal to G. What is this set A generated by A? So let me first give you definition of Yes, group generated by A. Let A belong to G and G is a group. Then the set S equal to A. This set includes all elements A to the power R such that R belong to Z. Okay, this set is the includes all elements of sorry for let A belong to G and G is a group. Then the set S equal to A to the power R such that R belong to Z is always a group and denoted by set generated by A or called group generated by A. So if we have an element A which belong to G and G is a group, so we are collecting the powers of A elements in which we have powers of A and that power can be any integer. So if we collect all those elements of which base is A and power is R, any integer. So like in this set A to the power 0, A to the power 1, A square, A cube, A to the power 4, A to the power minus 1, A to the power minus 2. All those integer powers of A will include in this set. So this is called the group generated by A. Okay. Now come to our definition of cyclic group. Okay. So what is cyclic group? Cyclic group is basically a group if there exists A belong to G such that set generated by A equal to G. So here we have read that this group generated by A means set generated by A is always a group. So all those powers of A will make a set and that set will be a group always. Okay. A group G is said to be cyclic if there exists A belong to G such that set generated by A is equal to G. For example, in Z8, you all must be aware of what is Z8. Z, let me remind you that what is Zn. Zn is basically 0, 1, 2 up to n minus 1. This is a set, okay, Zn in which 0 elements are there 0, 1, 2 up to n minus 1. So in Z8 we have elements 0, 1, 2 up to 7. So here we are saying that the set generated by 3 is equal to Z8. How it is? Let me show you. For example, 3 to the power 0. 3 to the power 0 is 1. Okay? 3 to the power 1. 3 to the power 1 is 3. 3 to the power 2. 3 because in Z8 we have binary operation addition modulo 8. So 3 square will be 3 plus additional modulo 8 3. So this will become 6. At 6, what is the meaning of modulo 8? A modulo 8 b will become the remainder when a plus b is divided by 8. So 3 plus 3 is 6 or 6. The remainder when 6 is divided by 8 will be 6. So 3 square is 6. Now we calculate 3 cube. What is, you can say it 3 square plus additional modulo 8 3. It will become, this was 6 plus 3 9. What is the meaning of this operation? The resultant will be remainder when 9 is divided by 8. So when we divide 9 by 8, the remainder is 1. So 3 cube is 1. So we'll do this process until we get the identity 0, because we are here in uh, additional modulo 8 in Z8. So what will be the identity element of this group Z8 under additional modulo 8? 0 will be the identity. So we'll do this process until we get the identity. So here we are having, this is 3 to the power 0, this is 3 to the power 1, this is 3 to the power 2, and when we do 3 to the power 3, you can calculate, it's easy. So when you will calculate 3 to the power 8, it will give you 0. So 8, what is 8? 8 is the order of the element 3. 8 is the order of the element. As we can calculate since we can calculate the order of the group, as well as we can calculate order of an element. What is order of an element? If we have an element 3 like this, so we want for example, let me give you definition. Order of, if A belong to G, then order of an element A is basically the least power n such that a to the power n equal to e. Okay, here 8 is the least power of 3 such that 3 to the power 8 is equal to 0. 0 is the identity of Z8. I hope you understood. Now here the set generated by 3 is equal to Z8. So this is Z8. So that's why this Z8 is a cyclic group. What is the definition of a cyclic group? A group G is said to be cyclic if there exists A belongs to G such that set generated by A equal to G. It is not necessary that all the elements should have this property, that set generated by equal to G. If we have any element of G, there exists any one or element of G such that set generated by A is equal to G, then we say that group is cyclic. Okay, here we have an example like Zn equal to set generated by 1. You can generate Zn, any Zn, 1, you are doing 1 square, 1 cube, 1 to the power 4. All these elements will be the elements of Zn. Z is generated by 1 as well as minus 1. So uh, this property uh, judges this, that set generated by equal to set generated by A inverse. This property I'm going to discuss with you is very important, that a cyclic group is abelian always. A cyclic group is always abelian, but abelian group may not be cyclic. Okay, a cyclic group is always abelian, but non-abelian groups is never cyclic. You should aware this of, you should be aware of this property, that if any statement P is implying another statement Q, so not Q implies not. Okay, if a cyclic group, this is a statement. Cyclic group is always abelian. So non-abelian implies non-cyclic. Okay. So cyclic group is always abelian. Abelian group may be cyclic or non-cyclic. Okay. Now the term is subgroup. What is subgroup? Subgroup is let G star is a group and we have a non-empty subset of this G set. Then H is said to be a subgroup of G if H is itself a group with respect to the same binary operation as that of G. So H is non-empty subset of G and H is said to be a subgroup if H star is a group itself. Not that the binary operation in which the H should be subgroup should be same with respect to the group G itself. So we denote it as H subgroup of G. For example, Z under addition is a subgroup of R under addition. R under addition is a subgroup of C under addition. So there are some examples. You can note it down. Now, if you want to test whether a subset H of G is a subgroup or not, so we have two-step test and one-step test. What is two-step test? If H is non-empty subset of G, then H is subgroup of G if and only if you take any two elements of H, product them, A dot B should be belong to H. Okay, A dot B belong to H for all A belongs to G, H, and A inverse belongs to H for all A belongs to H. For all A belongs to H, that is existence of inverse of any element of H. So if these two properties are satisfying for a subset of G, then we say that subset is a subgroup of G. Now one-step test. One-step test is saying that if H is non-empty subset of G, then H is subgroup of G and only if AB inverse belongs to H for all A comma B belong to H. So instead of showing two properties, you can show only one property, AB inverse belongs to H for all A comma B belong to H. This will prove that this H is a subgroup. So these were some basic terminology for the group theory. Without this, you can't start like normal subgroup. What is normal subgroup? Sylow subgroups. So in MSc from Maa Shakumbhri University syllabus we are going to cover. So the videos from the syllabus will be covered soon. So please subscribe my channel and like, share. Thank you so much.